Hello everyone, I'm Sachin Shrestha and warm welcome to you all to my this week presentation, video presentation of Cloud and Beyond, which is in the topic of managing the cloud infrastructure. This week we are covering four important topics that all are connected to how our modern cloud systems are built, monitored and managed. We'll start by looking at a monitor as a service, which in that section we'll be talking what it is, why it matters, and how it works in the practice, like in the real life, how it performs. From there, we will explore the budget awareness monitoring, which includes a smart approach that adjusts how closely a system is watched based on the available budget, and then we'll step back and discuss the five fundamental principles of a cloud computing, the building blocks that defines what cloud infrastructure is. And finally, we'll cover the REST, or REST, or also known as a short for representational state transfer, which is an architectural style used to manage a cloud resource via wave. So without a further ado, let's get started. Moving to the next slide, we will be talking on the topic of monitor as a service. And we'll be discussing why it is matter and why it delivers, what it delivers. Cloud environments are not as simple or small. They can involve hundreds, sometimes thousands of server, network devices, and storage systems, all running simultaneously. On top of that, there are massive numbers of using facing application relying on this infrastructure. When things go wrong in the cloud environment, whether it's a security breach, a performance drop, or a system failure, the consequences can be catastrophic. This is why monitoring is not an option, it is absolute essential. Cloud monitoring covers several key areas, which includes availability monitoring that ensures services are up and reachable, failure detection, identifying problems before they escalate, performance and provision monitoring, ensuring resources are allocated appropriately, security and anomaly detection, catching unusual behavior early, application level monitoring, watching how individual apps behave under the load. Now, rather than every organization building their own monitoring tool from the scratch, the cloud industry has evolved to deliver monitoring as a service. Just like how a cloud provider offers a database service such as Simple DBD, storage service like Amazon S3, and application platform like App Engine. Monitoring as a service, or YAM-AAS, bring the same convenience model to observability. It offers end-to-end support. It is well maintained by provider and allows the sharing of implementation templates, making it reliable and easy to adapt. And in this slide, we'll be talking about the monitoring as a service of the architecture. Like, let's now look at deeper at how monitoring actually works at a technical level. The simplest form is state monitoring. The idea is that we define a state value, let's call it a V, which is a scalar value representing something we want to track, like CPU utilization or average response time. We also define a threshold T. If V exceeds T, we have a violation, something needs to be done. In a distributed system, we scale this up, and with the distributed state monitoring, instead of tracking a single machine, we aggregate the state value V multiple objects, for example, measuring an average CPU utilization across all web servers in a cluster. This requires two key components working together: a monitor, which collects a raw state data from individual resources, a coordinator, which aggregates and analyzes the data across multiple monitors. Moving to the next slide, we'll be talking about the budget awareness monitoring overview. One of the interesting challenges that arise in the cloud monitoring is the cost. Cloud computing operates on a pay as you go model. You pay for what you use. This means that monitoring itself has a cost, and that cost comes directly out of the users or enterprise's budget. This brings us a budget as our monitoring, a dynamic approach to monitor that to adjust its resolution and granularity based on the available budget. There are three concepts here. First, pay as you go link. Cloud computing costs are directly tied to the monitoring spends. Second, the concept of overhead cost. When the monitoring system detects a violation, say performance is degrading, it may trigger an action like provisioning new servers. That provisioning itself consumes budgets, so that the cost of reacting to a problem is layered on the top of the cost of detecting it. Third, flexible provisioning. The core idea behind budget awareness monitoring is that we should be able to configure our monitoring tasks differently depending on how much budget we have available. Moving to the next slide, we'll be talking about the awareness monitoring of how it works. Like, so how does a budget hour monitoring actually works in practice? It boils down to two scenarios. When the budget is abundant, like when the budget is enough, the system uses fine monitoring resolution. This means it samples data frequently. It detects both mirror, trivial violation, and critical ones. Auto scaling reacts quickly to any changes in demand. Server are dynamically added as needed. Think of this as having your eyes fully open. You see everything. When the budget is limited, the system shifts to a coarse monitoring resolution. In this mode, simple frequency drops significantly to conserve the cost. Only the most important violation and flagged are acted upon. Servers may be dynamically removed to reduce running cost. The trade-off is that some minor issues may be missed. The key insight is the budget awareness our monitoring is adaptive. It is not all or nothing system. It smartly scale its attention based on what organizations can afford. So moving to the next slide, we'll be talking about the five principles of cloud computing. Now let's step back and look at the broader picture. The five fundamental principles that define modern cloud computing. Principle one: virtualization and automation. Cloud infrastructure abstract physical hardware into virtual resources. Instead of manually configuring server, tasks are automated. Principle 2: interchangeable or fungible resources. In cloud computing, the servers, storage, and network components are treated as commodities. Principle 3: single fabric management. All the resources regarding or of a type of location are managed in a single unified fabric. Principle 4: elastic capacity. Cloud infrastructure can scale up upon instantly and scale down instantly in a responsive to the business demand. This elasticity means organizations only pay for what they actually need at any given time. Principle 5: truly scalable application. Finally, the application themselves and the tools used to build them must be designed to scale out. This is grow horizontally by adding more instances rather than vertically by upgrading a simple machine. Moving to the next slide, we'll be talking about the representational state transfer, also known as REST. Our final topic is REST, representational state transfer, an architecture style that plays a crucial role in how cloud infrastructure is managed. REST was introduced by Roel Fielding in year 2000 as a part of his doctoral dissertation. It describes a set of principles for designing, distributing hypermedia system, essentially defining how software components should communicate over the web. So these are the three principles or the fundamental principle of REST. Principle 1, Uniform Resources Identifiers or URLs. Every resources in the system, whether it's virtual or a machine, virtual machine or a storage bucket or a network devices, it references by a unique URL. This makes our resources addressable and discoverable. Principle 2 is for HTTP methods only. RESC restrict how resources can be manipulated to get just for operation, get to read, post to create, and put to update, and delete to remove. Principle 3, stateless interaction. Each request between a client server and server is fully independent. The server does not retain any memories of the previous interaction. This makes REST system highly scalable and fault tolerant. And moving to the next slide, we'll be talking about the summary and the conclusion. To wrap these things up, today we covered monitor as a service, delivers a cloud monitoring as a scalable shared service covering availability, performance, security, and abnormality detection across a massive infrastructure. Second thing we talked about is was the budget awareness monitoring, and third thing we talked about the five principles of a cloud computing, and at the last we talked about REST provides a clean, stateless, URI driven approach to manage the distributed cloud resources under using a standard HTTP methods. So this is all for this video presentation. Thank you for your work. Thank you for your time, and thank you for the thank you for your watching and listening. And if there is any question raised or asked, please comment it down in a question. Comment it down in a section. Comment down section below, so I can reply back to you. So and thanks again, and have a good day.